So it's pretty obvious with the rectangular method that when the function f of x is rapidly changing, that you're going to get some huge errors in your estimate here, right? We have these huge empty areas that are not being accounted for. And so the trapezoidal method manages to handle that quite a bit better. And so we'll start here with our a is x0. We'd like to end where xn is at b, and we're going to break this up into n slices. And instead of going straight across and creating a rectangle here, we're just going to connect the two, right? And so that's going to give us a much better approximation here as we go along. And this, of course, makes a trapezoid. And so, well, then we need to know the area of the trapezoid, right? So the area of a trapezoid is just we have to add our two heights here, right? And we'll take 1/2 times the base times the sum of the two heights. So now instead of just needing this endpoint, right, which is f of x0, right, this is x1, I now need also f of x1, right? And so the area, or my first area here is going to be f of x0 plus f of x1 divided by 2, and we'll just multiply that by delta x. And we know that delta x is just b minus a over n from the last from the rectangular method. Okay, so now I need to keep going, right? So I need to add f of x1 plus f of x2 over 2 times delta x, right? And I need that because I am calculating the next trapezoid, and I need both of these values, right? So you can see I needed these two values for this trapezoid, for the first one, and I'll need these two for the second. So I've actually reused one of the function evaluations here. And we'll see that that happens again and again all the way until the last one, right? So this is xn minus 1 and xn. And so I'll have f of xn minus 1 plus f of xn divided by 2 times delta x, right? And so this is going to get repeated, this is going to get repeated, all these are going to get repeated on the inside, but these two on the outside are not repeated, right? So we can kind of, we can pull out the delta x just like we did before. We can pull that out in front of everything. We can pull out the 1/2 in front of everything as well. And what we're going to end up getting on the inside is f of x0 plus 2 times f of x1 plus 2 times f of x2 all the way down to 2 times f of xn minus 1, and then I'm just going to have f of xn at the end, right? And so we can just look at this as really three pieces, right? I have this piece here, and then these, right, which is really just 2 times the sum, right, from the first step to the second to last step here, right? And so I could write that as delta x over 2 times, right? And so I have f of x0, right, plus f of xn plus, and now I need to sum everything that's on the inside here, right? And so I'm going to sum from 1, right? I start at 0. I'm going to sum from 1 to n minus 1, right? I don't want to go all the way to the last one. I've already included that here. And that is going to be f of xi at my index, right? And so that right there then is going to be what we would like to code up for the trapezoidal method.